Question 23. If n is the element of whole numbers, so it's some whole number, solve permutation of 2n plus 4 pick 3 equals 2/3 n plus 4 pick 4. Now this one really comes down to understanding the definition of a factorial and then some basic algebra. I won't say the algebra is really easy, but it's not really hard either. It's just a little bit tricky. So let's see what happens. Okay, so by definition, this first one here says start with this number and take 3 numbers. So I'm not going to go with the actual factorial part. I'm just going to start with 2n plus 4. And then I'm going to multiply that by the number below it, which is going to be 2n plus 3. And the number below that, which is 2n plus 2. So that's all a permutation is. Start at the n or the first value, the first thing in the bracket, and take 3 numbers in this case. The other side, I'm going to do a kind of 2 things at once here. Instead of writing 2/3, I'm just going to write 2, and then I'm going to multiply both sides by 3. So the 2/3 becomes 2 on that side, 3 on the other. And on that side, we have n plus 4, pick 4. So I'm going to start at n plus 4, go number below it, a number below it, and a number below it. So I started at n plus 4 and took 4 numbers, each one smaller than the number before. Okay, now there is a trick here, and hopefully you might notice it. You can cancel out something here. I mean, if you try to expand this right now, you're going to get a huge mess. It's theoretically possible, but very nasty. What I would do is notice that this and this both have factors of 2 in them. So I can write this as 2 times n plus 2. There's still a 2n plus 3 there. And I can write that one as 2 times n plus 1. Okay, now that I'm there, I can cancel out the n plus 2 on both sides, and I can cancel out the n plus 1 on both sides. That's going to make this significantly nicer to work with. In fact, I can also cancel out one of the 2's with that 2, and I think that's it. Okay, so on this side, I'm left with 3 times 2 times that, which is really just 6 times n plus 3, 2n plus 3. And on the other side, I just have those 2 factors, n plus 4 times n plus 3. I can't simplify much more yet, so what I'm going to do is expand this out. That gives me 12n plus 18. And on the other side, n squared plus 7n plus 12. If you expand it out using FOIL or whatever method you learned, you might get one extra step in there, but it's going to simplify to n squared plus 7n plus 12. From there, I'm going to move everything to the right-hand side because I can. So n squared stays. 7n subtract 12n will give me negative 5n, and 12 minus 18 will give me minus 6. At this point, you can use the quadratic formula, or if you remember how to factor, you can do that. I'm going to factor it because factoring is just a little faster, and I don't have to worry about using up a lot of space. This is going to be n minus 6, n plus 1. And that means that n equals 6 or n equals negative 1. Now, going back to my original equation, I'm going to note that n equals negative 1 is not going to work, partially because the question actually says n is a whole number and negative 1 is not whole, it's an integer. But also, if I plug it into the second permutation, the one on the right-hand side right here, that was not the tool I wanted. If I plug in negative 1 there, negative 1 plus 4 is 3. I can't say here's 3 objects, pick 4 of them in order. It becomes undefined. And as a result, this is an invalid number. So this is my correct answer, n equals 6, and you can verify it easy enough by plugging it in for n and checking to see that it actually does work.